later, so you can come back to this and refer to it all the time.
Okay, so now we know what an array is, and so array is the basic data type in NumPy, and it actually also handles matrices or tensors. So you can like just put another dimension here. So you can put here a tuple saying 5 by 2, and then you get a 5 by 2 matrix.
Is this array class just numpy, or is this somewhat compatible with the usual Python base?
No, this is just NumPy. Yeah, but you can easily import just so Python has built-in lists. So let's say L equals 1, 2, 3, whatever. So this is a Python list, and you can just convert it to a NumPy array by saying numpy.array, and then you put here the usual Python list. So then you have this. So the background is that so the usual NumPy lists do not support any mathematical operations, like you cannot add two vectors because the size can also differ, and so for the NumPy operations, always the BLAS routines are used internally. So everything should work with large arrays as it would be in MATLAB. It's just the same library. Okay. So far we had just 0 arrays. We can also, of course, create some, for example, 1s. So it's just the same as in MATLAB. If you want to have random matrices or vectors, there's also random. So let's create a 5 by 2 random matrix. Here it is. Okay, and you can, of course, do the same stuff you would be able to do in MATLAB, like add stuff, and yeah, what else? So let's take another matrix. What you need always in MATLAB is the I matrix. It's just the same in NumPy, so 5 by 5 diagonal matrix with 1s on the diagonals, also I. If you want to specify diagonal elements, you can also use the diag command like in MATLAB, also the same. You can put here a regular list if you wish, for example like this. Oop. Here's the diagonal matrix. Transpose, yeah, it's .t. So, but this isn't very okay. This as expected.
Can one somehow list all the available variables?
You mean the available commands, or
The variables like workspace.
workspace?
It's who.
It's also who? Yeah, who?
I didn't know.
Yeah. And who's, yeah, it's also prints the size and the memory of the elements. Yeah.
These matrices are sparse.
No, those are just full matrices. But there's sparse matrix functionality. Okay. So let's, what do we have here? Okay, we have a matrix 5 by 5, and we have a vector 5, or not a vector, it's also a matrix 5 by 2. So, but we should be able to do something like this. However, this doesn't work. So the matrix multiplication is a bit different in NumPy. You have to explicitly write NumPy dot and then a comma v, and this gives you a times v. So this is I'd say the most significant difference between MATLAB and Python code, that you have to write numpy dot for a dot product. Yeah, otherwise you could do something like a times a. This is the entry-wise multiplication. But usually you don't want to do this, so be careful. What else? Okay. Python has very fancy thing called list comprehension. So you could, for example, create the squared numbers from I squared for I from 0 up to 10, and you can write it just like this. So this gives you the squared numbers from 0 up to 10. So okay, and of course you can just plug this in again into diag or whatever you want. And if you want to have a numpy array, you can do it like this. Okay.
So there's a basic difference between a list, which is more or less a set, but
Yes.
can also contain different entries. It doesn't have to be all of the same, like integers.
Yes. So for example, you can, if you do it like this, you could put some string or something at the end. Oh, it works. No. One. So you have a string and a list, and this doesn't make any sense if you want to do computations. So there's the numpy array, and the numpy array can only contain one data type. So, but there are arrays for integers, for doubles, and so on. So, but normally you would just use double and integer.
Complex if you want.
Yeah, or complex, of course. Yes. Okay. Let's. Oops.
So you have arrays and matrices in MATLAB. That is a 5x1 matrix is automatic vector, and
Yeah, that's a good point. That's actually a good point. So if you do a vector just like this, so what would MATLAB do in this situation? You would get a 5x5 matrix with this, but here you get a vector which is a one-dimensional vector. If you want to have a column vector, you should put a 1 here. Oh wait, you have to do it like this. So this is a tuple, and then it's actually a column vector. So
matrix vector multiplication. You can also work with an array, or it's like matrix multiplication. Matrix vector is the same. Or
so the dimensions actually have to match exactly. So you cannot. I think you cannot do a 5x5 matrix times a vector, a one-dimensional vector of length 5. I think it doesn't work.
I see.
No. And so we thought a long time about this problem, and we decided to actually always explicitly give the dimension here, because otherwise it's so messed up and you don't know if it's a one-dimensional array or a two-dimensional array, so 5x1 array, for example, and so we always explicitly type a 1 here.
So like a method is very nice.
Yeah, so in MATLAB this is a bit nicer in MATLAB, but yeah, on the other hand it's just a 1.
The difference is that MATLAB only knows arrays with, it always has 2 dimensions,
Yeah.
5 and 1, or 5 and 5, or whatever. In Python it can have any dimension. There can be an array with just 1 dimension, which would be a vector, or 2 dimensions, which would be a matrix, or 17 if you want, right? MATLAB can't do that. But for this generality, can be a bit tricky sometimes.
Yeah.
You can't do? Perfect. Okay. Fine.
But I think it always like thinks of stuff as 2-dimensional literacy. So a vector is just a matrix which just has 1 column.
Right. Okay.
Okay, so let's move on. Just a few more things. So let us take again a random matrix. Let's say 10 by 3. And so let's assume you want to have the QR decomposition of this matrix. And there's a subset of numpy called linalg, which has all the linear algebra functionality you would expect in MATLAB 2. And you can always...
This was PEP.
Yeah, so this is a very nice feature of ipython. You can always press tab and you can see all the functions in the current namespace. So here we have, for example, ike and inf, and here's QR. So let's just use QR of u, and okay, looks like this. Let's see if it's really orthogonal Q. You would do this with dot and then type u t for transpose, comma u, which is crap. Q, okay. Oh, nice. Okay, and R is upper triangle. Okay. Okay. Yeah, I think all the rest of the functions you can look up. So the numpy documentation is quite good. Just Google. Okay.
We have backslash operator.
No, there's no backslash operator in.
It's called inf.
It's
Yeah.
no, inf is the actual inverse.
You
There's
have to make to choose a
there's a function called solve which does the same as backslash. So numpy dot linalg dot solve. This you can also was it question mark? Yeah. If you put a question mark in front of some function, you get the help of the function. So this is
Really
this is
like backslash?
yeah,
and
it's
in the sense that it solves, and also if you have undetermined systems.
so we know that backslash does some magic and wrong stuff, but so this actually just uses the BLAS solving routine. So it doesn't do any computation by itself. It's just passing it to BLAS, as far as I know. LAPAC. Here is. Yeah. Okay. Okay, documentation doesn't work, but you just Google for numpy documentation and then you will find everything you need. Sparse matrices are contained in another package which is called SciPy. This is a bit more advanced package. You also have stuff for quadrature or for statistics and for whatever.
And if you put now dot and tab, is it
Yeah,
okay?
you get everything inside. And so if you don't want to write always the word SciPy, you can do something like import SciPy as SP, and then you can use SP. Yeah, 3 characters less. Great. So that's actually more or less a convention to also use numpy as np. So if you see np somewhere in the code, you should recognize it as numpy. Okay.
So you import numpy as nothing? As standard?
No, but you can do something like
very title writing.
from numpy import, for example, zeros, and then you can just use zeros. So
You can import like anything.
you can do this, but this is this is not very nice, because if you have a function in your namespace that has the same name, it gets overwritten. And yeah, so be careful with this. Just you can use this. You can also use here more functions here, and this is the nice way of doing it.
So these are static methods. Is this numpy some sort of class, and these are all static methods in this class?
No, actually, it's a module. There's a difference between a class. You can also use classes or object-oriented programming in Python. But so this is a module, and there's a difference between.
I'm used to writing Java code where everything is a class or an object. So
No, it's not like that.
So there's a concept of a
Of a module, yes. Yeah. Okay, so I'd stop here. If you have any important questions now we cannot resolve later, then feel free to ask them.
Is linear algebra on numpy is always LAPACK calling, or is this some different method?
I think everything is LAPACK, yes. I think so. I don't know every command.
Standard libraries, and we have classes with LAPACK that work with ICE, for example. Or APAC.
Yes, there's in the SciPy there's also APAC. Okay, so
Big matrices can work there in Python?
so like in MATLAB, as much as your memory allows. So the overhead for Python is very minimal, like in MATLAB also, more or less. Okay, MATLAB uses a lot of memory when it's starting, but yeah. So what dimensions have we used? For I don't know, 100,000 or 500,000 is okay. So
you
for a
can
vector.
use as large matrices as you can use in MATLAB too.
Yeah.
There won't be any difference.
The only limitation is your memory. Yeah.
Are there some tools also for parallelizing? Like in MATLAB, this tool is parallelizing the process?
Actually, I haven't checked this in Python. So shared memory is, I think, difficult in Python.
But it's also difficult in MATLAB. When
Yeah.
you say
I mean, I just recently found a code where they use it, but in our computers there is no this.
The toolbox
so
isn't
I
present,
haven't
yes.
tried,
That's
so I
right.
don't
Yeah.
know if it's good or not.
well, the parallelization in MATLAB is mostly on the level of loops. You know, when you have a loop over 50 things that and each iteration, or the iterations are mutually exclusive somehow, or you can compute them in parallel. This is half or something like this. This is usually, when you talk about parallelization in MATLAB, this is what you're talking about. I think you can do the same thing in Python as well. There will be import some package par
Yeah.
Python or whatever it's called. You know, but we will find out about that when you Google it, I guess.
Okay, so I hand over to Jan.
I just wanted to show some nice features of the ipython shell that well, will make it more effective in working, and I found them very nice, and maybe that makes the transition from MATLAB to ipython or Python easier for you. So it's basically about profiles. As we had it in the talk before, in order to use these all this functionality of numpy, for example, you should start with import numpy as np, for example, and then you can use this. all these functionality to have this available. I think you will soon figure out that whenever you start ipy, you start with import something as something for a couple of times. That's where the notion of startup scripts come into play. It's basically you can define a little script that is executed every time you start ipython.